Welcome Math 252. We're working on problem 59 from section 6.2 of the Hughes-Hallett text. In this problem we've been asked to evaluate a definite integral, which I've got written here. We've got the integral from 1 to 2 of the quantity 1 over y squared divided by y. We're integrating with respect to y. And we're supposed to do this both exactly and numerically. By exactly they mean we're supposed to get an answer like the natural log of 3 or 5 minus the square root of 2, and by numerically that means we're supposed to come up with a decimal answer that's an approximation to our exact answer. So the thing to do when you're doing integrals, this problem is asking you to find an antiderivative for this fraction that's written there, and it's not maybe obvious to you what the antiderivative is. It's not obvious to me. The thing you want to do is apply the basic rules of algebra and the facts that you've learned about integrals to try to make the problem simpler. In other words, break it down into simpler problems that you can do. And so I'm going to show you how to do that. I have a friend who calls this the ABCs of calculus because you want to do algebra before calculus. So here's the integral from 1 to 2 of the quantity we're working with. And all I've done here is do a little bit of algebra to rewrite this integral as a sum. The reason I've done that is because you can split integrals, whether they're definite or indefinite. You can split them across sums and differences. So I've rewritten the integral, as you can see, as the integral of a sum, and then I split it into two integrals. So I've got the integral from 1 to 2 of 1 over y dy, plus the integral from 1 to 2 of y, which is what y squared over y simplifies to. The thing about that is I know how to do both of those. I can look at those and tell you what the antiderivative is for each of those expressions. I know that the integral of 1 over y is natural log of y. In other words, I know that the natural log of y is an antiderivative for 1 over y. And so I can evaluate this definite integral, the one on the left, simply by evaluating natural log of y at 2 and subtracting what I get when I evaluate natural log at 1, which is exactly what I've got written here. Similarly, I know that an antiderivative for y is the quantity y squared over 2, and I can evaluate the definite integral by looking at y squared over 2, evaluate it at 2, evaluate it at 1, then take the difference of those two quantities. And so that's what I've written. And so down below I do that. First we have the natural log of 2 minus the natural log of 1, and then we have y squared over 2 evaluated at 2 and evaluated at 1. A little bit of simplification. Remember that the natural log of 1 is 0, and if you didn't know it, 2 minus 1/2 is 1.5. Good thing to know. So what we've got here is the natural log of 2 plus 3/2. And then if you like, you can run over to your calculator and see that that's about 2.193, and if you're interested, you can get more decimal points. You could also do the entire integral on your calculator and you'll get the same answer, but I think this way of doing it gives you a little more insight.